Okay, uh, good evening, students. Then today we will continue with our first chapter in physics of class 12, that is the modern physics part, which is very easy. You can learn very easily this part. That's why I am continuing with this part. I will try to cover this in two lectures. So, first, before going into the modern physics, we have to learn some basic things. Okay, first let me give the heading here, that is modern physics. Now actually physics is really love for some students, na? They love physics. Even I love very much this subject. So you have to study with feel this subject. You have to feel actually. Physics is a subject of feelings. Unless and until you don't feel the phenomenon, you cannot solve the sums related with any phenomenon of physics. So in modern physics, firstly, before going deep, you have to know about electromagnetic waves. I would like you all to note down, okay? First, you have to know about electromagnetic waves. Now, this word waves, you have come across with this word wave in your class 11. You know very well about the wave. What is wave? Wave is a disturbance which propagates within a material medium. Right? You have learned very well that in case of sinusoidal waves, the graphical representation is this way. Not going into the details, you have learned many things about this sinusoidal waves in your class 11th. So we have learned one important thing in class 11th, that wave needs a material medium to propagate. Wave needs a material medium to propagate. But the difference with electromagnetic wave is that electromagnetic wave do not need any material medium to propagate. Electromagnetic wave do not need any material medium to propagate. This is the basic thing about electromagnetic wave. There is a chapter called electromagnetic wave where you will go into this thing very deeply. Okay, and now just remember this one. The electromagnetic wave is a kind of wave which do not need any kind of material medium to propagate. We will learn further about this in the chapter called electromagnetic waves. Now, students, let us know one fact, that light is an electromagnetic wave. Okay, this is a fact which you have to know before going into modern physics, that light is a electromagnetic wave. Now, this is a fact that light is an electromagnetic wave. Same way, there is another fact called light has dual nature. Now, about this dual nature, you have learned in your class 11 chemistry. What is dual nature? De Broglie's hypothesis that every material has two nature. One is wave nature, and other is particle nature. Now, some phenomena of light are explained with the help of wave nature, and some phenomena of light are explained with the help of particle nature. The phenomena of light which are explained with the help of wave nature is like diffraction, etc. I am not going into the details. And particle nature is like photoelectric effect by Einstein. Photoelectric effect. Now, students, in this modern physics, the first topic which we will learn is photoelectric effect. Photoelectric effect. Photoelectric effect. Now, who gave photoelectric effect? The great scientist Albert Einstein gave photoelectric effect. Okay. So the first topic which we will learn under the topic under modern physics is of photoelectric effect. Okay, these are the basic thing. First, what is electromagnetic wave? Light is electromagnetic wave. Light has dual nature, wave and particle. Some phenomena of light are explained with the help of wave nature. Some phenomena with the help of particle nature. Photoelectric effect by Einstein is explained by the help of particle nature. Okay. Now let us come to photoelectric effect. Okay. मैं मानता हूं कि कुछ भी चीज पढ़ने से पहले हमें उसका हिस्ट्री बहुत अच्छे से पता होना चाहिए. ठीक है. साइंस के स्टूडेंट के लिए भी हिस्ट्री बहुत ही इंपॉर्टेंट है, क्योंकि अगर आपको यह पता नहीं होगा कि साइंटिस्ट ने कैसे उस फेनोमेनन को डिस्कवर किया, तो आप फील नहीं कर पाओगे. ओके, दिस इज द ब्यूटी ऑफ द सब्जेक्ट, दिस इज द ब्यूटी ऑफ साइंस. ओके, कम ऑन, लेट अस कम टू photoelectric. Let us come to photoelectric effect. Now see, students, what is photoelectric effect? Photoelectric effect is a phenomena by which, with the effect of light, electrons are emitted from the metal surface. If this is a metal, light comes here and an electron from the metal surface is ejected out. This is called photoelectric effect. Now, going into the process, going into the deep phenomena, how is this taking place? We have to know that the particles of light are called as photons. Particles of light are called as photons. As I said, that light has dual nature. We are speaking about the particle nature of light. And the particles of light are called photons. Now, this particle of light carry a certain amount of energy, which you have learned in your class 11, that energy of photon is equals to h nu. Energy of one photon is equals to h nu, where h is Planck's constant, and this nu is frequency. This is frequency. Now, this word frequency is related with wave. Okay, but we are speaking about particle. This shows the dual nature of light, that light will have a frequency. We are speaking about particle nature of light. Still, we are speaking about frequency of light. Okay? Okay. So, a light of a particular frequency, the photon of a light of particular frequency. The photon of a light of particular frequency will have energy equals to h nu. Photon of a light of a particular energy will have the value of energy to be h nu. Are you getting this? They will have the energy h nu. Now, students, as the photons are coming and striking the metal surface, these are transferring the energy of h nu into the metal surface. They are transferring the energy of h nu into the metal surface. Therefore, let us come now into the deep phenomena. This is the outside portion of metals. This is the outside portion of metals, and the electron in the surface are here. Electrons in the surface are here. Just one second. Okay, so this is basically the barrier. Okay, This is the metal barrier. This is the outside portion. This is the outside boundary of the metal, and the electrons on the surface of the metal are here. Now, when the light comes, when the photon come of energy h nu, this will push the electron outside. This will push the electron outside. But for crossing this metallic barrier, the electron will take certain amount of energy, and that energy is called work function. That energy is called work function. After that, the electron will come out with the remaining amount of energy. Now here, what is the energy of electron? According to the law of conservation of energy, if H nu is the energy which came and pushed the electron, and work function was amount of energy taken to cross the barrier, then the electron will be left with the remaining amount of energy. And what is the remaining amount of energy? E is equals to total energy H nu minus work function, and this work function is denoted with the sign phi, and this is called Einstein's equation of photoelectric effect. E is equals to H nu minus phi. So this is everything about photoelectric effect. This is the most important equation which you have to remember while studying the photoelectric effect. Now, how do the scientists study photoelectric effect? We have to know about a circuit. You have to know about a circuit to study the photoelectric effect. Now, the circuit in which we will study photoelectric effect, let us construct the circuit. You see. Just I have drawn the simple version of this circuit. There is a better version. Okay, so this is a tube. Okay, this is a tube. Now, the wall of this tube are made of glass which are transparent to light. Now, this much amount of potential V is applied across these two plates. This is the negative potential plate. This is the positive potential plate. Light comes and strikes this metal plate, and electrons are ejected out. And it goes towards the negative plate. Now, understand nicely. H nu is the energy of photon which came and strike the metal. Remember, one photon will eject one electron. There are many photons coming, so one photon will eject only one electron. Okay, one photon will be equivalent to one electron. They will eject one electron. Now, this H nu is the energy of photon. They come and eject one electron. Let us consider here phi is minimum. Phi is nearly equals to 0. We are neglecting phi here. The value of phi here. So the electron will come out with the energy equals to H nu. According to a law of conservation of energy, if phi is 0 and H nu minus 0 is H nu, so they will come out with the energy of H nu. Clear? Now, you see, electron are of negative sign. Electron are negative charge, and this potential is of negative. So this plate will try to oppose the flow of electron. Will try to oppose the flow of electron, right? They will try to oppose the flow of electron. And the potential difference across these two plates are V. These two plates are V. So the work done on electron, when going from here to here, will be what? EV. Q into V. We have to know this one, that when from one point to other point, suppose here potential is V1 and here potential is V2, and Q amount of charge moves from this A point to B point, then work done on this charge Q will be Q V2 minus V1. So this is the thing here. The work done will be E into V. This is the work done on electron. And we know work is energy. So if electron is coming out with the energy of h nu and the opposite work of EV is done on the electron, then when the value of h nu will be equals to EV, then the flow of electron will stop. Yes or no? It is very clear with the fact that according to the conservation of energy, according to the work is energy. So if electron is coming out with the energy of h nu and a EV amount of negative work is done on the electron, and when the value of h nu becomes equals to the value of EV, then the flow of electron will stop. Now this amount of potential V is equals to h nu by E is called stopping potential. Is called stopping potential. And if the electrons are flowing from here to here, then this will constitute a current on the opposite side, current I, and this current I with the help of photoelectric effect is called photoelectric current. Okay, now we have to understand one more term, that is I, not current. This I is not current. Let us constitute this current with small I. This I stands for intensity of light. Now what is intensity? Intensity means number of the photons which are coming per unit time. If intensity is small, then number of the photons which will come and strike is more, then number of the electron coming out is more, therefore the current constituted is more. Therefore the photoelectric current will be directly proportional to the intensity of the light coming. So if we draw the graph between the photoelectric current and intensity, it will be straight line passing through the origin, because if intensity is more, then the amount of photoelectric current will become more. Why? Because intensity means more number of photons. If more number of photons, more number of electron. If more number of electron, then greater is the current. And if greater is the current, then this is the relationship which you obtain, the intensity directly proportional to the current. Okay? Okay. Nextly, let us come to last phenomena of this lecture, to the last thing of this lecture. You see, after the striking of light, as the current passes, the current becomes constant with time. Okay? Current cannot increase up to infinity. Current will become constant with time. Okay? Now let us see that graph, the variation of current with the voltage applied. If this is the voltage, if this axis is the voltage axis, okay, this voltage, and this is the current, then the nature of graph will be this one, and this point will be the stopping potential. Okay, this will be stopping stopping potential. Why? Because you see, this is the negative potential. Okay, this is the positive axis, this is the negative axis, and I have said that when this amount of V will increase, then more amount of negative work will be done against the flow of electron. The flow of electron will stop and the current will fall to zero. And as the value of potential is decreasing, that means the negative value is decreasing, the positive value is increasing. As the positive value of potential is increasing, as the positive value of potential is increasing, as the positive value of potential is increasing, then we can see that the current increases and it becomes constant with the flowing time, and this constant current will be called as saturation current. Saturation current will be called as saturation current. Okay, this is the thing about photoelectric effect. We will go more deep into the modern physics in our next lecture. Till then, stay safe and contemplate upon this. Thank you. Jai Hind.